Well, people often ask how you get started on a trip, which other people think is rather unusual. And for any of you, you ask yourselves, when did you get first interested in something? Is very hard to tell, because in my case, I grew up in the Canadian Rockies. My parents were very enthusiastic outdoor people. They mountain climbers and skiers, and they even had a dog team. And they were interested in geography, and so were my teachers. And my first job was connected with looking at the weather and the ice and the flow of the waters and the rivers around Banff in the eastern Canadian Rockies. And that made it possible to somehow think that the whole world is an interesting place for nature. And pretty soon, if you go to school and learn about the globe, the Earth being a planet, you see Canada is an interesting part of that. And it has a cold north and a warmer south. You look at the whole planet, there are cold places and hot places everywhere. And pretty soon, if you're good at skiing and climbing mountains, you get jobs where you can have fun doing what you think is interesting and important. And what happened to me was that I studied geology and surveying, and I was working in northern Canada, northern BC, and the northern Yukon. And we were busy with studies up there when a bunch of English mountaineers came and said they were planning a trip to Antarctica, and they wanted somebody who knew how to go up mountains without falling down and knew how to drive dogs, and would I like to do it? And so I was already busy in the north, but it seemed like a good thing to do. And in the early summer of 1949, we went over to England and joined a bunch of other people, and we just took off for the south and didn't come back for 3 years. So that is how we got involved. But behind all that fun, there was a lot more interesting things going on. What had happened was that people had been studying what's happening to the planet and the climate. And there was a Swedish professor who had been looking at the glaciers in Sweden and Norway and Greenland, and found that they were quite different than they used to be some hundreds of years ago. And he was very interested in the fact that the whole North Atlantic Ocean looked as if it was warming up. And so he wondered, now, was that just around the Atlantic Ocean? He came to Canada and he looked at what was happening to the Canadian Rockies and to the glaciers in the north. And then he thought, is that just the whole planet, or is that just the North Atlantic area? And nobody knew what was happening to the glaciers and to the climate in the southern part of the whole world. But after the Second World War, there were some pictures taken by a German exploring expedition just before the war, which showed some glaciers that looked as if they were getting smaller. And so they must have changed, either the climate or something had happened. So he talked to the governments in Norway and in Sweden and in England to say, let's send a trip down to Antarctica to see whether the changes in the glaciers and in the climate in the southern part of the Earth was the same as what was happening to the north. And so to do that, we had to have an expedition. We had to have a bunch of different kinds of scientists. We had to have some way of getting around to look at different parts of Antarctica. So our expedition went down there. in those days when you didn't have long-distance radios and didn't have aircraft that were organized the way they are today, you couldn't go down and back quickly. So we had to go down 1 year on an icebreaker and plan to. There's no point in turning around and come back because you'd have to do some real work down there. So you'd stay down there a second year and come back the third year. And so that is why I went down there with a team of about 10 scientists and a bunch of helpers. And we went down in 1949. And of course, the season's different, so we arrived there in the summer, which is in the summer of 1949-50. And we then the next summer, we built a house down there. We stayed at a camp, and then in the summer the next year we went far inland with dog teams because there was no airplanes or anything like that that could carry us in that region at that time. And we spent the whole summer there traveling by dog teams. We came back, spent the second winter, and we had a short trip in the following spring, and then the ship came and picked us up, and we came back in 1952. So people say, how did you spend 3 years down there? Well, I can say that's about the shortest time you can do any work down there.
A little bit about the dog trip.
Well, I think you know quite a lot about what Antarctica is like. Most of it is covered with ice. It's a big, thick, in a simple way, it's a great big snowfield. Under the snowfield is a great big glacier which is moving. And only here and there the mountaintops stick through. Or at the edges, of course, the glacier breaks off and you see the mountains and the shore, the rock around the edge. But from the point of view of humans, there's nothing growing there that you can use or to eat. And that is one of the reasons why there's nobody that ever lived there permanently. And so if you're going to stay there for a while, you have to take all the food with you. And of course you have to bring everything with you for heating. And you have to build your own buildings. There's no towns or anything except the ones that have been more recently built to serve scientists. And that's all brought in from somewhere else. So we went down the first time to a place that nobody had ever been before. We didn't even know exactly where it was. We had to just go find some place we could land. And land a ship and build our land a ship and build our camp. And we had with us then food, which in extreme emergency would last us for 5 years if it didn't come back. But we planned to stay there for 3 years, so we had 2 years spare food. And it had to be the kind of food which would not spoil, and which could keep people healthy if you're eating the same thing all the time. And when you were traveling out in the inland on the glaciers and traveling in the mountains, you had, of course, you couldn't carry very much. We were using dog teams, and the dogs had to carry everything for them to eat and for us to eat also. And so everything had to come with us. So it had to be concentrated. And the best food for that anybody has ever found is concentrated that way is the pemmican which the North American Indians used and the Canadian Indians used in the north, which was meat and fat pounded together with a little bit of berries and fruits which would contain some vitamins and some minerals to balance off what was in the meat and the fat. But you get your energy from the fat, you'd get your tissue replacement from the protein in the meat, and you would have these berries and things mixed in with it to give you some vitamins. And so that was a very good food to keep you alive. It isn't a very good food if you're fussy about the taste. And the other trips to the polar regions in the Arctic and the Antarctic had played around with how to make that best they could. And the most useful form of pemmican that had been developed by the time we went down there in 1949 was stuff which is, if you just wanted to look at it today, you'd say it's sort of like thick dried gravy. It was brown and rather fatty. If you heated it up, it melted. If you put boiling water on it, it made it a kind of a soup. And so you had a choice. You could have pemmican soup, you could have pemmican stew, you could have pemmican drink like instead of tea or coffee, or you could have a chunk of pemmican just dry and chew on it for lunch. But it was just the same food all the time. And yet, a small plate of that would give you enough energy for a day. So with by a lot of trial and error, we developed what we called a sledging ration. Our daily food was about a pound of this pemmican stuff, and then to add a little bit more energy and make it smoother, we also had about half a pound of butter, straight butter, and then we had 4 small biscuits, which were called ship's biscuits that your parents would know about, but you don't get it anymore. But a little bit like this Rivita stuff, only it's thicker. The big thing about those biscuits was that they had no crumbs, that they're really tough, and when you bite into them, they bite right off. So you don't waste a single calorie by spilling a crumb when you're eating it up. And so durability was equally important as the energy, because everything you carried, you wanted to go into your tummy and not be left on your plate. And it had to be something which did not go moldy or dry out too much after 3 years in a box. And so we had 4 biscuits, we had our pemmican, we had a pad of butter, we had I think it was 17 or something like sugar cubes, just to give some sweet and a little some sweetness if you wanted it. It really wasn't very important, but it helped to think that things would go down. And then a little bit of either dried potato or oatmeal. We alternate each day for either a potato soup breakfast or a porridge breakfast. And it sounds today, if you say that, quite dull. And yet, I think all of my friends who are with me down there would say, once you're using that, it's satisfying, and you want more of it. You don't have great visions when you're dreaming of T-bone steaks or fresh fruits, although it'd be nice to have it, but there's nothing like that around, so that's it. And so we stayed healthy, very healthy, for long trips. And away from our base camp, the longest trip that I happened to make was a little over 6 months without coming home at all, 189 days. And we had everything on our dog sled when we started out. And as we ate up the food, we picked up rock specimens because we were doing geology to study the land. And so we came back with a load of rocks and went out with a load of food. And the dogs were just the same. They had a similar kind of pemmican for 2 days, and then on the 3rd day we gave them a piece of dried fish and a little bit of margarine butter, just to give them a little bit of a break. And the dogs stayed healthy, and they had almost the same food that we did, and it just showed that that food was a very good food for being your main support day after day and month after month.
How many miles did you go?
Oh, gee, I have no idea, because we went back and forth and round and roundabout. Because when you're doing surveying, doing studies, you don't keep track. It's like how many miles do you do when you're playing around the schoolyard? I don't know. You're running all the time. But I can say that what we did in our studies, if you can think of Antarctica like a big pie, and there's 2 slices already taken out of it on either side that nature took out, and that's called the Ross Sea side and the Weddell Sea side. We were on the edge of the crust on one side of that, and we went into it about a quarter of the way from the edge to the middle. And that was a distance of, we ran into a mountain range which is 500 kilometers in, and we went along that mountain range, surveying every main mountain, all the valleys, for a distance of about 1,200 kilometers, back and forth. So we studied an area quite carefully, which is about 1,200 kilometers long and about 500 kilometers back from end to side. Then one trip was made, which I was on part of it, but one of my friends did the longer part, farther inland with explosives to try to do what they call seismic sounding to get the depth of the ice, see how deep the ice was away from the mountains down to the rock. And they went in another 200 kilometers farther in that, just a single line in. There's nothing showing in there. It was just smooth, flat ice, and it would have stayed that way all the way to the South Pole. And later on, when people got long-distance airplanes, of course, they flew over where we went, and you could see it's just flat all the way. We didn't miss any main mountains, but we weren't that far from the pole.
So that was the longest unsupported trip at its time, eh?
Yeah, it used to be.
How would you word it? How would you say it?
Well, I don't know. Sometimes, there's rivalry among different expeditions. And right from the time of Captain Scott and Amundsen and Shackleton, which were the explorers that everybody knows about, there was always, not the people doing it, but the people back home trying to say, who went the farthest, who went the longest, and so on. And so there was this kind of rivalry. And different trips went out and stayed for a month or two, and somebody stayed a bit longer, and so on. And we just happened, because we had good food, like I mentioned. It was dull food, but it was good. We had an excellent team of dogs, and everybody knew how to drive their dogs, and they kept the dogs happy, and so on. So we stayed for a long time. And so our trip, just over 6 months, without anything to supply us in between times, was the longest trip that was ever done. I think it is often useful to think about those old technologies, because I don't think there's anything else except a satellite up in space now that can go off for 6 months without getting refueled. We carried all the fuel for our engine. Our engine was 17 dogs on my team, and for ourselves. All our heating, there was no stores or anything to go along. We had all of our tents with us, so all our accommodation, everything to live with in cold temperatures on one dog sled, and it was there for 6 months without having to refill anything. We did get towards the end very short of enough fuel. We used kerosene for our stoves. We were very, very careful not to waste any, or not to have the stove burning just for comfort, because we needed it to. We had to melt all our water. You couldn't just get fresh water, and so you had to be very careful how much fuel you used to melt water, and for your food if you wanted to have a drink, and also to cook with. And at the same time, you wanted to use that heat to dry your frozen stockings. And so we did get short of fuel, and we made it, though. That was okay.
That sounds like an amazing trip.
And everybody came back healthy.
What did you study when you were there? What did you study when you were there?
They had several main kinds of studies. The most important reason for going there, as I tried to mention a bit earlier, was to see whether or not the climate was changing in the south the same way as it was in the north. And that would give us an idea. Is the whole planet changing, or is it only changing in spots? And we did that study by not only measuring the climate, but looking at what's happening to the glaciers, because the glaciers, of course, get bigger when it's more moisture coming down, and more snow coming down, and also when it's cold and not melting. And they get smaller when it's warmer and it's drier. And so, and every time the glaciers go ahead and move forward, they drag some rocks from underneath them, and then when they move back, they leave them behind. And if you can date those rocks and see what happened, you can tell the story of the way the glaciers have moved and the way the rocks have weathered, and that tells you what the climate's been doing. And if you can get the age of the time of these things, you can see what's happening. So that was our most important thing, to look at the glaciers, and then naturally we wanted to see what was Antarctica made of.
Every continent is made of rocks, and the rocks
tell the story of the whole Earth. Were there any fossils in it showing who lived there before humans came? Was there any minerals in it that people might want? Was there any evidence that Antarctica was different in the past? And we found quite early evidence that Antarctica is a continent which once was joined to India and Africa, and it has skidded from being up in more warmer climates in the past, where there was big swamps that made coal and things like that, and it skidded right down south and got stuck over the South Pole. And we were able to study the rocks and see their structures and their shape and what kind of fossils they had in them, and get the dates of the rocks and see how they joined up with their partner rocks and partner continents, you might say, in India and in Africa and Australia. Australia also split off, and it skidded off to one side, and it's stuck there now. So we were studying the glaciers, the geology, the climate. But to do that also, we had to make a survey and a map, because so we know where we are and other people go. So we did surveying at the same time. So that was our main activities.
That's great.
I think that what is interesting and important to all of us in the future, no matter how old or how young we are, is to realize that we live on a planet which is all connected. We do not live in separate little pieces. And Canada is a fairly big country, fairly big, that's not huge, as some people think, but it's one of about 190 to 200 countries, depending how you do it. And we live on a continent called North America, which is one of 7 main big land masses, which they call continents. And we should be aware that we are one animal on a bunch of other living things. And that is fascinating not to know. But some parts of the world we don't know much about. And we are richer if we know a little bit about all parts, just as we're wiser if we know a little bit about all the different other kinds of life there is on this world. And so if Antarctica, which is a part of the world which is outside the experience of most people, because nobody has lived there in the past, and it's not an easy place to go and make a living, because there's nothing to eat and no jobs there unless you take them with you. So it's a very interesting and important addition to your perspective and knowledge from any kind of interest you might have, to have it as part of your background, to understand that in places where no humans have done anything, there are millions of penguins all dressed up in their evening dress, waiting to go somewhere, and surviving quite happily without anybody looking after them. It's interesting to know that even though the continent is covered in ice, all around it there are whales and seals, and the ocean is being enriched chemically there, and is feeding the fish, being the rich ocean which carries waters that feed fish throughout the whole world. I think we in Canada are very conscious of winter and summer, and how the climate changes and the seasons change. If you lived in California, you would not be quite so conscious of it, but you are here. If you try to start your car in January, you know it's different sometimes than it is in July. Particularly, you have to shovel snow to get out of the driveway. Why is that? Well, because the continent is different at different places. And when you begin to understand how these changes, then you find that the southern polar regions, Antarctica, and the big ocean around it are some of the main the main reasons what happens there to why our weather changes even in Canada. And if we don't try to understand what's happening, then we're simply at the mercy of something saying, well, it was hot last week and it's rained this morning, and the farmers don't know quite what's going to happen today. The wheat crops on the prairies. It's true, but isn't it much better to see the overall picture, see what happened, to get ready for it? So all of our studies in Antarctica have a reason that ties in to what happens to us at home and what happens to people in other parts of the world. We see that there are famines and droughts in other parts of the world. There's a cause for that, which may be local because everybody's cut down the trees, or it may be part of a broader natural thing, and if we understand that, we can be a bit more ready for it and do things better. And the same is happening in our politics, that we often get really concerned about what we're doing in our own country, but we know very shortly that that what we do is affecting and is affected by what happens in other parts of the world. And in fact, the Canadian soldiers are over in Afghanistan now is one good evidence that we can't just look at what happens in Canada itself. Well, there are parts of the world where we have learned a lot of lessons about how to get together and live together as different kinds of people with different value systems and things like that. And just by good fortune, because there was no people living in Antarctica beforehand, the people who have gone there over the last 100 years, first they were rivals for exploration, and then they thought, well, maybe they should try to make money out of the resources, but the resources they could get easily, like whales and seals and so on, were very quickly killed, and so they lost those resources. And that showed how greed in a commercial system destroys the very thing we were working on. But after that, that was perhaps not very happy part of our history. But after that was finished, people said, look, we can get more value out of cooperation. And different countries began to work together saying, look, we are really destroying what usefulness and what interest there is in that area by squabbling over it. Let's get together and work peacefully and in cooperation. And so the end of that was that for the first time in the world, a treaty was made by a large number of countries, not just between two quarreling countries like the treaty at the end of a war, but by a large number of countries to get together to cooperate in how to manage their affairs and look after a whole part of planet Earth. And so the Antarctic Treaty covers 1/6 of the whole planet. 1/6 of the planet. And nobody owns it. Some people have made claims in the past, and in order to avoid quarrels, they say, well, just put your claims aside. We won't say that you don't own it, but put it aside. Come on, everybody can use it. And the countries agreed to do that. So now there are 47 countries that have signed a formal agreement of their governments at the highest level in the government, saying we will cooperate and all will have an equal interest in making sure that Antarctica is a continent of peace and a continent of conservation and preservation. And the main value for Antarctica, that why countries want to keep working there, is for the scientific information that they can get from it, which tells us about our droughts on the prairies, or it tells us about what happens to toxics and the poisoning of the planet. I think you all know that the uncontrolled use of things like hairsprays and paint sprays and things like that, and use of some of our fertilizers has gone up into the upper atmosphere, the ozone layer, and has caused that layer which filters out the harmful rays of the sun to be thinner, and so the sun rays which cause cancer on people and on animals, and also stops the plants from making proper buds and from being fertile, that is getting thinner in some places. And where it was measured first is in Antarctica, because you could see right there whatever chemicals that were in the atmosphere were not made in Antarctica. There's no factories in Antarctica. And yet that's where the ozone hole was thinnest, and it was really affecting the climate. And now we see that it's happened in the Arctic too, and there's good reasons for that, because it's in the cold atmosphere that these chemical reactions take place first, but then they're spreading. And now every morning when you turn on the radio, you get the ultraviolet index, because it gives you an idea how much you can stay out in the sunshine without getting serious burns. The information that is needed to give that on the weather every morning comes initially from Antarctica, because the measurements of the ozone hole in Antarctica are the background from which you measure it all. So these kinds of important scientific information from Antarctica, which the countries get by cooperating, couldn't have been at all in the minds of Captain James Cook and Scott and Shackleton when they were just exploring new lands. They thought it was interesting because they wanted new knowledge. They didn't know what it was going to be used for. Now we use it to give us a weather report in the morning which tells you how to avoid skin cancer. Okay, who goes to Antarctica? At first it was the explorers and the ship captains, and then later on it became those who wanted to make money out of whaling and sealing. But one thing about the Antarctic continent that is different than all other continents is that there was never a military expedition to Antarctica in order to conquer it or to have a war there. However, because it is such a beautiful place, at least in part, and because it is sort of mysterious, in the last little while, when tourist ships became possible to go to any part of the world, tourists went to Antarctica. And it was a long way away, it was expensive, and yet to be comfortable and not in an expedition, you had to have quite a strong organization. And these tours were led by young adventurers mostly, people who wanted to be guides to tours. And among those people there was a young man called Geoffrey Green, who had been a school teacher before he became a tour guide. And he thought, why do I spend my time taking old, rich people who won't be really doing anything the rest of their lives except amusing themselves down to Antarctica when as a school teacher, he said to himself, I know how much more that the young people, students who are still studying, still trying to figure out what they're going to be doing in life, could get from such a trip. So he began to think of a way that students could go to Antarctica instead of rich old people. And the end result of this is that a lot of other people tried to help him, and he made some good arrangements, and he got the schools to cooperate, and everybody that he talked to got excited about the fact that really the best kind of people to go to Antarctica were young people, and it was part of a broader education. And the education could be education about geography, about science, about history, about politics. No matter what a student was going to do in the rest of his life or her life, having some experience in Antarctica, seeing nature as it is in a place where humans haven't messed it up too much, and seeing how other people who are down there as scientists are really curious to find out what our world is like, that would be a good kind of a classroom to have students go to. And the best age for that is in the middle of high school, before you get too tangled up in all of the rest of the career, before you're really sure what you want to do, but when it's necessary to know as much about the world as you can. And so Jeff Green and his friends and his partners developed this scheme whereby they make Antarctica into a classroom. And the Canadian group of students on ice was the first time we've tried to make the whole of Antarctica as a classroom. It also helps that because the seasons in the Antarctic are reversed, summer and winter, you are in Canada, that it's possible during the winter holiday in the middle of the school term to go down to Antarctica where it's the summer down there. And so it's worked out that now we have a tradition of high school students going to Antarctica in the Antarctic summer, which is the winter break in the ordinary Canadian school. The students on ice has now run 2 expeditions. Some of the old-timers don't like to call them expeditions. They are 2 learning trips to Antarctica. They're not just tourist trips because, as you know, the students who go to Antarctica work very hard. They have to study beforehand something about the history and the geography and whatever part of the science or nature is of interest to them. When they get down there, they have to watch it carefully. They have to learn from the scientists who tell them about the oceans and the creatures and the climate and how studies are going there and how that relates to back to Canada. And then we hope that the intention is they will all come back and make some reports and tell their students and their teachers about it. It's been possible to take about 50 students down each of the last 2 Antarctic summers, and we hope it'll continue. So now at least 100 kids have had good fun, sure, but worked hard and learned about Antarctica from being right there. They put their feet on the ice, they stand on the rocks, and they walk among the penguin rookeries without disturbing them too much. And so and they even learned that sometimes their fancy new cameras don't work in the cold, but that's okay. It's great for the scientists who are working in Antarctica too, to go down with a bunch of high school students, because as you well know, students can ask embarrassingly simple questions which are very hard for scientists to answer, and they come directly to, why does this happen, or what do you do this for, and is it really true that the penguins swim faster underwater than the fish and the seals so that I can catch them? Then you can actually see that happens. And so the scientists learn a lot from the students. And for those of us who've been lucky enough to go with the students on ice trip, we have not only had the joy and satisfaction of trying to do a bit of teaching and explaining about the interesting things that we're studying, but we have extra fun watching the kids themselves learn and tease us about how sometimes what we think we know about nature is not true at all. And so it's great fun for everybody to learn from that. And I think also in the trips that I've been on, we've seen that the ship captains and the crew, who are sometimes pretty stiff people because they have to run their ship like a very strict rules, and it has to be very careful of the safety and all that. But when you get a bunch of enthusiastic high school kids on board, the ship gets a lot looser, and the captain and the mate and the seaman, they enjoy it too. At the same time, you have to learn some discipline. If you're going to jump from a big ship in the cold into a bobbing up and down Zodiac boat, you have to learn very carefully to obey instructions, or else splash, and that's the last time you learned it. One of the nice things that has come out of our 2 years of taking students to Antarctica has been that the teachers who are with us and the scientists and the students are all together. We're very informal. Everybody is learning from everybody else, but the big teacher is nature itself, and that you don't need to make a break between the enjoyment of new experiences and learning and increasing your knowledge. You have fun while you're learning. You learn while you're having fun. This is not a pure pleasure trip that the students are on, but it is a very pleasureful learning trip, and it's great fun. And I think that the idea that you can have a lot of fun while you're learning something is something which we want each student to bring back and to realize this is true in the rest of school things too. There are lots of unexpected surprises and things that one doesn't really know how they're going to turn out or what they're going to teach you when you go to Antarctica, because it is a land of such strong contrasts in nature being rather cold and brutal sometimes, in the fact that the scenery is different and stark from almost anything else you've seen. The animals that you see, the whales and the penguins and the seals, are living in a way that is just not familiar to people who look at dandelions and sparrows and deers in the park. And also the history is a bit different, and there's many things that mix all together. Instead of studying history in a history lesson and geography in a geography lesson and geology in a geology lesson, you find that they all mix together. On the trips that we've had on the way home, we've stopped at an island off Antarctica before we got into the Drake Passage, which is called Deception Island. And different people know different things about that island, because for one thing, it isn't what it looks like. It's deception. It looks like a round big island. When you come to it, there's a hole in the middle of it, and it is just a horseshoe instead of a round island. The horseshoe makes a great harbor, but it is the crater of a volcano. But it's not an extinct volcano. It's an active one which blows up every little while. But because it's a good harbor, people use it, even though it might blow up. And so from about 1907 or 8, I think, the whaling companies built a whaling factory and they had it at a harbor to make whale oil when people used to hunt whales for whales. And they got great arguments about it. And then different countries claimed the island before the Antarctic Treaty. And so there was even a slight, not quite a war, but the Argentinian people built a station and the British government built a station, and they tore each other's station down. And then they made peace for a while and played football back and forth, and then they tore the station down again. So students could see this and get some idea of the complicated history of the world in which we live, because it was not fighting about Deception Island. It was fighting about two countries who argued about resources. At the same time, the whaling factory was built as a big plant to boil up carcasses of whales. It made a lot of money, but then they used up all the whales. The whales were killed in that area until there was really none left. It wasn't worth it. So the companies abandoned it, and the students go there and they see the wreck that's left of what was in their grandparents' day a very modern technical plant. And you see what happens to it. If technology gets so efficient that it uses up all of the living resources. So it teaches us a lesson about management of our resources. But then all of this is happening on top of an active volcano. And every once in a while the volcano goes poof. And it's done it about every 2 or 3 years in the last 50 years. Not very seriously, but when it sends off a bunch of rocks into the air, wherever they land, that becomes serious. And so when the students go there, they can find, parked alongside one of the buildings, a Canadian Otter aircraft, which was down there to do survey work for the British government. And the volcano went poof, and rocks went up in the air and came down through the wings of the airplane. And if anybody wants a cheap airplane, you can have it. It's down there. It's not much good to anybody. And so in the midst of all that, we have politics, we have economic greed, we have nature acting up all by itself, and because the volcano is still active, the sand on the beach is warm, and you can take a nice warm swim in cold weather when it's snowing, because there is baseboard heating all around your swimming pool, and it gets steamy and it's comfortable. It may not be very clean, but it's great fun. And so students who would go to Antarctica, they can say they've been swimming in the middle of a volcano and it's hot.
Fred, is there anything in Antarctica named after you? I know you're humble, but it's got to be something there.
Well, we have surveyed and studied the geology of one of the mountain ranges that lies inland from that part of Antarctica, which is from South Africa, if you can picture where it is. And that part, when we went down there, first time we got in there was 1950. Try it again. The first time we went in there was 1950. Nobody had been into that part of Antarctica at all, so there was no names for any of the geographical features. And so we made a map. We didn't put names on the map. Surveyors don't do the naming, it's other people. But after the map was compiled in Norway, one of the mountains, sort of mountain groups in that area, was called Roots Mountains, or Roots Heights.
Can you show me on the map there?
Are you focused here? If this is all of Antarctica, here is the part of Antarctica which goes up and joins with South America, and up on this side, South Africa is up here. And we were studying right in here, and Mount Roots is right there. South Pole is in the middle here, and the big station of the United States and Sweden and New Zealand is in this region here. France has a station over here. Russians have a station in the middle, but in here there's a South African summer station, but there's no other main station. Oh, there's a Japanese station over there. Okay. This is where Mount Roots is, right in here. Again. Mount Roots is a mountain group right in here. And it's made of very old rocks, rather like the Canadian Shield. The Antarctic Treaty is a treaty between governments to ensure that all of the activities in Antarctica are peaceful and that they are a benefit to all of humankind, not just a benefit to a single company or a single country. And so it's a cooperative treaty. There isn't any other one like it, except there is one in the Arctic, in Spitsbergen or Svalbard, where about 15 countries, including Canada, have agreed to cooperate. But there, Norway does the governing, because it's considered Norwegian territory. In Antarctica, according to the treaty, all of the countries who sign the treaty agree that they will not make any claims of territory, that they will not forbid any other country or people from any other country to go to their territory. They agree that they will not carry out any military activities directly, and that they will share all the information they get from scientific studies. The treaty has several parts to it, some of which have to do with the management of the resources of the sea, the whales, the seals, the fish, and so on. And it has a section which they call a protocol to protect the environment, which watch very carefully there's not any environmental damage. Different countries have different degrees of direct involvement in the treaty, but if they sign the treaty, they agree to all those main things I just mentioned. Canada is one of the 47 countries that signed the treaty, and so we agree to abide by all the rules. We have not signed all of the arrangements about protection of the environment because it's very complicated for the Canadian government to sign that. Some of the requirements are really not Canadian government responsibility, they are provincial government responsibilities. We have to organize that in ourselves here. We require some new laws in Canada. But we're working on it. Canada has said many times that it is in favor of all of this, but to make our laws just like that is rather a slow process. But it's coming. The treaty is managed by an international meeting held once a year, and then there's subcommittees under that. And so Canada sends its representatives to those meetings to take part in the discussions about just what are the next issues. And some of those are setting aside places where nobody should go. For example, a protected area, not even scientists, except under very special conditions, so you don't disturb something. Other parts are to make sure that we all use the same well, practical things like same radio wavelength for search and rescue. So if a Dutch plane falls down someplace, the people from India and from Canada can both look for it using the same radio frequency. You can see that's very, very important. And it's not easy to do that without a treaty. The treaty once a year is held. Next one's going to be in Poland in September, and I'll be representing Canada at that, as I have been for the last few years. Sometimes one wonders how much real influence on the development of politics and decisions about the economy and so on students can make. And particularly in Antarctica, where no students live there, but the Canadian students have been there in a very special, privileged position. No other high school students as a group has gone down there like that. And so on the very first trip that we made with students, the students got together on the way back. It wasn't quite as rough in Drake's Passage as it is sometimes, and they wrote what they thought was a statement from all the students that said what they felt about Antarctica and the role of youth in the future, and how countries really needed to act and to put into practice all the promises that there are in the Antarctic Treaty. And so the Canadian Youth Statement on Antarctica came out of the first Students on Ice expedition. When we have the annual meetings to look at the governing of Antarctica, they're called Antarctic Treaty Consultative Meetings. Each country states what they think is important from their point of view to make the treaty work better. And so it was with great happiness that I was able to put before all of the other countries at the international meeting the statement from the Canadian youth about the future of Antarctica. And so it was copied and distributed to everybody who was there. That was at the meeting from all the 46 countries. It was translated into the different languages of the Antarctic Treaty, and so the statement from the Canadian youth became a formal part of the record of the Antarctic Treaty meeting, and as such, that's an influence on politics. And I must say that when I went back a year later to the next meeting, we heard from Japan and from Chile that they were inspired by the Canadian Youth Statement and were hoping that their youth would also have an opportunity to say what they think about the future of Antarctica. There are some things that are that are important in the history of Antarctica that Canada has played quite a part, and I think Canadians should know about it. As you have heard said many times, one of the main activities in Canada, in Antarctica, Antarctica, is scientific study. And perhaps it should be remembered that the very first expedition to Antarctica that spent a winter there was in 1899-1900, and the chief scientist on it was a Canadian, Mr. Blackwall Evans, who came from Alberta. He had a farm near Crossfield, and he was a big, strong fellow who was also a good scientist, a zoologist, a geographer, and a person who classified plants and things like that. And he was very well known in the polar exploration circles, but because he was never a professor at a university or anything like that, a lot of Canadians don't even know about it at all. However, a year or two ago, when we were having some revisions of the maps of Antarctica, a glacier named after him to record his earlier work there. There is a glacier, another glacier, in the main mountain section of Antarctica and near McMurdo Sound on this part from New Zealand, which is called Canada Glacier, and it's one of the most studied glaciers. And that was because on the second Scott expedition, there was a Canadian called Andrew Taylor, who was a person who did very careful geographical studies of the bare rock valleys, which they call the dry valleys, because there's not ice in them. And Dr. Taylor was so enthusiastic in studying this particular glacier that it was named after him. Later on, he became a professor of geography at the University of Toronto, and is one of the first of Canada's polar scientists. So there are lots of background. People will have heard about the first flight right across Antarctica by an airplane by a man named Lincoln Ellsworth. But perhaps they forget that the man who flew the plane, Ellsworth was not the pilot, the man who flew the plane was Mr. Hollick Kenyon from Manitoba. He was a bush pilot from Manitoba, and Ellsworth knew that he was so experienced as a bush pilot and able to keep his airplane running even if it was forced down and fix it up, that he hired him specially for that trip. And so as Antarctica has been explored and studied and so on, there's never been a big Canadian expedition, but on one expedition after another there have been Canadians. One of the most important expeditions to Antarctica was a series of studies, what was called the International Geophysical Year. Some people call it the IGY. And it was from 1957 to 58. And one of the important studies on that was to look at the electricity in the air, the physics of the atmosphere, and to study how the southern lights, the aurora, worked with around the South Magnetic Pole and things like that. The chief scientist of that was a fellow named Frank Davis from Canada, and later on he became in charge of the Defense Research Board studies near Ottawa, and he was also very instrumental in Canadian Arctic studies too, and began the whole teamwork of studying between the high Arctic in Canada and Antarctica. And so if you begin to study a little bit about who was involved in the evolution of knowledge about Antarctica, you'll find Canadians there every little while. And right now there are about 15 or so Canadians working in Antarctica.
That's great.
Canadians have been involved in knowledge about Antarctica right from the very beginning. The Canadian was the chief scientist on the very first wintering expedition in 1900. A Canadian was involved in was a pilot of the first airplane to cross Antarctica with Mr. Ellesmere, and from that there have been very many Canadian bush pilots who have gone down to Antarctica. The Canadian company did the first aerial survey, air photography survey in Antarctica, and a Canadian chief scientist was in charge of the physics of the International Geophysical Year. We have many, many examples of Canadians working in Antarctica without there having been a Canadian expedition to Antarctica. But perhaps the most frequent Canadian visitors to Antarctica is the Arctic Tern. The Arctic terns are born in northern Canada, and once a year they go all the way down across North America, South America, to the edge of Antarctica because it's summertime down there, and they come back again. And sometimes we wonder whether it is wise for students from Canada to go to Antarctica and burn up jet fuel back and forth on the way. And it certainly has perhaps a poor effect on the environment. But think of the Antarctic tern. They are Canadians, and they use energy to go back and forth every year, and they don't affect the environment at all, but they keep it healthy. That can be a goal for all of us. And if we have a chance to ever to go to Antarctica, we will learn a lot. But just like the Arctic tern, you have to study before you go to know something about it. Don't just be surprised when you get there, because unless the Arctic terns have learned from their flock how to go, they might end up in Bermuda or in Mexico or somewhere else, and they might even end up in somebody else's dinner. Antarctica is a continent that is the most separate from all other land masses in the world, surrounded by the world's biggest and most continuous ocean. Antarctica is a bit larger than Canada in area, not quite as large as all of North America. Most of it is, well, it's all covered by ice, and most of it is flat and featureless, and you wouldn't know one part from another unless you were really very knowledgeable. But there are small parts of it which are scenically some of the most beautiful places on Earth. The coastline, where there are mountains reach the sea, are some of the most spectacular mountains that be found anywhere. There are active volcanoes in Antarctica. One of them, Mount Erebus, is very well known, and to geologists it's amazing because the only other large volcanoes of that kind of composition are found in Kenya in Africa. And so that helps to show how Antarctica and India and Africa were once part of a single continent. But the other side of Antarctica is rather like a continuation of the mountains in western North America and western South America. The Andes Mountains go around a big loop in the Southern Ocean and continue in West Antarctica. And on that, there are also volcanoes. And those volcanoes are not much different than the volcanoes of Garibaldi in BC or Mount Rainier or Mexico and so on. And one of the volcanoes of that kind, where you can go swimming in the equator, is in Deception Island. And I don't think you should try it in Garibaldi. So learn about Antarctica, go to Antarctica, learn from Antarctica, and let Antarctica teach you about the world in which you live.